You know that feeling, right? It's a ridiculously hot day, you walk inside, and that wall of cool air hits you. And you just think, how? How on earth does a box just make cold air? Well, today, we're going to pull back the curtain on one of the most common yet least understood bits of modern magic.
Okay, let's start with the single most important idea to get your head around. Your air conditioner isn't creating cold. Not at all. It's actually a heat mover. Think of it like a high-tech heist. It's grabbing all that unwanted heat energy from inside your room and just tossing it outside. So that's the real question, isn't it? How do you steal something you can't even see, like heat? Well, it all comes down to this really clever, endlessly repeating cycle that is the absolute engine of every single air conditioner on the planet. We're about to look at what's called the vapor compression cycle. Now, I want you to think of this cycle as the four-chambered heart of your cooling system. It's this constant, powerful pulse that keeps the whole thing running, and it all works because of one beautiful, fundamental rule of physics.
This is it. This is the secret sauce. You know how when water evaporates off your skin, it makes you feel cooler? Well, a special fluid in your AC, it's called a refrigerant, does the exact same thing, just way, way more powerfully. That simple act of a liquid turning into a gas is what literally sponges up the heat from the air.
So let's walk through this heartbeat step by step. First, inside your house, you have the evaporator. This is the heat sponge. A super cold liquid refrigerant boils and turns into a gas, sucking heat out of your room in the process. Next, that gas travels to the compressor. That's the muscle. It squeezes that gas, making it incredibly hot and high pressure. Then, that hot gas moves to the unit outside, to the condenser, which acts like a heat dump. It releases all that stolen heat into the outside air and turns back into a liquid. And finally, the expansion valve is the reset button. It instantly drops the pressure, making that liquid icy cold again, ready to go back inside and pull off the heist all over again. Okay, so that four-step cycle, it's perfect for your bedroom or your house. But what about a skyscraper or a massive shopping mall? You can't just slap 1,000 window units on the side of a building. For that, you need a totally different kind of beast.
Yeah, for big buildings, we're talking about the air handling unit, or AHU for short. And honestly, the best way to think about it is this. If that vapor compression cycle is the building's heart, the AHU is its giant set of lungs. It's what breathes all that conditioned air into every single corner of the building through this huge network of ducts.
So let's just put them side by side. Your home unit, right? It uses that refrigerant directly in the coils to soak up heat. But a massive commercial AHU, it often uses a different tactic. See, there's a central plant called a chiller that makes just tons and tons of ice-cold water. That water then gets pumped up to the AHU's coils, and that's what cools the air for the whole building. Same principle, just a massively different scale. And if you were to look inside these giant lungs, you'd find a few key parts. There's a mixing box that blends the stale air from inside with fresh air from outside. You've got heavy-duty filters to catch dust and pollen. Of course, you have those giant cooling coils filled with chilled water. And finally, a huge, powerful supply fan that pushes all that perfectly cool, fresh air out where it needs to go. Now look, having a powerful heart in strong lungs is great, but without a brain, it's just a big, dumb machine. Modern cooling systems are incredibly smart. They have to be, because it turns out it's not just about managing temperature. It's about mastering the delicate science of air itself.
And this right here is the real challenge. We've all been in a cold, damp basement, right? You know that feeling. If you just make the air cold, but you don't pull out the moisture, the humidity, you get that awful, uncomfortable, clammy feeling. Real comfort is that perfect balance between temperature and humidity.
And that is where the building management system, the BMS, comes in. This thing is the central nervous system. It's the brain of the whole operation. It's constantly taking in data from hundreds of sensors and making smart decisions every single second to maintain that perfect balance. So, how does this brain work? Well, one of its smartest tools is something called a VAV, or Variable Air Volume Box. Just picture an empty conference room, right? Instead of blasting cold air into it all day long, sensors can tell that nobody's in there, and the VAV simply closes a little damper to cut off the airflow. It's so simple, but it saves a tremendous amount of energy. It's brilliant. The system also gets super precise with its control. It uses some clever math, a PID loop is what they call it in the industry, to hold a really steady temperature. So instead of a simple on-off switch that makes the room get too cold, then too warm, then too cold again, this system is always making tiny, smart adjustments. It just smoothly cruises right up to the target temperature and stays there. And maybe the cleverest strategy of all is the economizer mode. The BMS is always watching the weather outside. If it's a beautiful, cool day, say 55 degrees, why on earth would you spend a fortune running that giant chiller? You wouldn't. The system is smart enough to just open the dampers and use all that free, cool air from outside instead.
So, we've gone through the physics, the huge scale, the intelligence behind it all. But why does getting this right matter so much? Well, the impact is staggering.
In a typical commercial building, the entire HVAC system, that's the heating, ventilation, and air conditioning, is responsible for almost 40% of the building's total energy use. 40%. That is a colossal energy footprint.
And when you get right down to it, it's all about this. Good design is everything. A system that's properly sized, that uses all that smart logic we just talked about, well, that's the difference between a truly sustainable building and what folks in the industry call an energy vampire.
So the next time you step inside and feel that amazing rush of cool air, just take a second. You're not just feeling cold, you're feeling the end result of this beautiful, complex system. A heat heist that's always in motion. A high-speed game of thermal tag where heat is always it, and it always gets thrown outside.